Hello, welcome to the accelereyes website. This is a brief tutorial designed to show you how you can accelerate your MATLAB code on the graphics processing unit or GPU. Jacket makes this really easy to do with a few key functions. One of those is ginfo that gives you system specs about your GPUs. So in this system we have two CUDA capable GPUs. One is a Tesla C1060 with 4 GB of RAM. It's capable of single and double precision arithmetic, and it's the one that's currently in use. We also have a GeForce for visualization purposes, and I'll provide a teaser of our graphics toolbox a little later. Since we'll be running a benchmark, I want to show you we're running in Windows XP with a dual-core CPU. Okay, now let me show you how we can use Jacket. We all know that we can create a matrix of random numbers in MATLAB using MATLAB's rand command. So here I create a 1024 by 1024 matrix. Similarly in Jacket we can create a matrix on the GPU using Jacket's gdouble command and simply cast A to A underscore, and now A underscore is a 1024 by 1024 double precision matrix that lives on the GPU. And that's as simple as it gets. Now we can do everything to A underscore that we would want to do with A, but the difference is that any operation we run on A underscore is going to get executed on the GPU and going to get accelerated. So for instance, if we want to do a silly command where we just take the 31st element of A, multiply it by the 54th element of A, we can do that, and we can run the exact same thing on the GPU. And notice that the result now is a GPU result. Any function that you run on a GPU value will result in a GPU value. And so if you chain a lot of functions together, you're going to get optimized kernels running on the GPU with Jacket automatically for you. You don't have to do any GPU specific coding. And then at the end of the day, if you want to bring the result back to the CPU, you just use MATLAB's regular old casting command to bring that back to the CPU, and we can run that, and B now is the same as answer was, but it now lives on the CPU. In Jacket 1.3 we have a bunch of new features. We have a lot of new linear algebra functions with the Jacket DLA add-on, double precision linear algebra. We have LU, QR, SVD, matrix inverse, eigenvalue decomposition, and many other functions. ML divide, for instance, that will help you in solving linear systems. In this simple snippet of code, I'm going to benchmark the LU function for you right here. So I'm going to create a 1500 by 1500 matrix of random numbers in double precision on the CPU, and then the GPU is also going to be double precision. I'm going to run that for 5 iterations and then take the average to get the CPU time. And same exact code down here with the exception of a few additions with the gsync and gevals. These are necessary to get an accurate timing due to Jacket's lazy evaluation optimization that it makes. These keywords, gsync and geval, are only needed when you're doing timing of snippets of code. They're not needed in general practice. And then at the end of the day, I'm going to print out the GPU speedup, which is the CPU time divided by the GPU time. Okay, so let's run this. The script is called LU underscore example. I'm going to run that. It'll take a few seconds, and boom, there we go. We got 4.5x speedup. The GPU took 0.08 seconds. The CPU took 0.38 seconds, and the inputs are X there, and the outputs were Z there. And then to show you really quickly, we can look at X underscore and Z underscore. We can look at those directly on the GPU with Jacket's graphics toolbox, which does cool OpenGL rendering. We can use, for instance, the gimage command to look at these matrices. So X underscore is just that random matrix. It's not going to be too interesting, just a random image there. But Z, the LU decomposition, is then looks like this sort of diagonal image there. I encourage you to check out Jacket, check out the graphics toolbox, check out the double precision linear algebra. It's all cool and new stuff in Jacket 1.3. Thanks a lot. Talk to you later. Bye.